afternoon, ladies and gentlemen. This is Prahlad from Bosch Digital Twin Industries. Today we are going to talk about a story like how to make the things which are not invisible to you and make it visible. So this is a story of a geothermal power plant where all of you are associated with. You need this energy in the form of heat and in form of electricity to keep your daily routines running. And how do you make this invisible thing visible is all this story about. So the challenge underneath, it's below your foot, and this is not something which can be easily seen. And if you look at this image, this is an image of a geothermal power plant, and if this power plant doesn't function, you're going to have tough time during the winter season. This system looks very simple, and you feel like everything is fine, but the real problem is below. And this is a problem which you cannot see it, but you can feel it. And this feeling is very painful, and I don't want anyone to face this. So what is happening here, friends, is this power plant extracts energy from the Earth's core, where the energy generated in the Earth's core is being transmitted to a solution called as brine or it's water, and this needs to be taken out from the surface to the surface from the bottom. And the height of this well typically can range between 700 meters to even a kilometer. And this system is like a heart. You know what happens in your body when your heart functions? Then you have the blood circulation to all parts of the body. But if the heart doesn't function, then the problem starts. Here as well, when this pump which you're seeing here, if it doesn't function, then you don't have heat in your home, and then the actual difficulty starts. But managing this asset is exactly like the way we manage our hearts, to keep it safe, to keep it healthy. But the problem here is, how do you monitor this? Because this is underground, underneath, 700 meters down. How will you put a sensor there? It's impossible. But if you don't monitor this, then the problems are just few meters or few days away from you, knocking doors, saying that, hey, look, here I come, and have some fun time during the winter season. We need to prevent this situation. So, how do we monitor this asset? The best way is to build a digital twin of this, but for building a digital twin of this asset, it is going to be tremendous amount of effort which we need to put in to make this twin function. So how did we do it? We first started building the brain of it. And when you build a brain, it's not like, guys, I'm going to put some sensors, take the data out, and use a Grafana dashboard and show the insights. It doesn't work like this. We use the first principles and physics. First principles are nothing but your fundamental equations which define the boundary conditions in which this pump has to operate to keep your power plant working. So how did we do this? Here you have got the power plant, and below that you have got the pump. So we have a big data acquisition system here, or a distributed control system, where you take the data which is already available in the plant, the electrical data, vibration data, pressure, mass flow, all these things. In addition to this, the as-built diagrams, the CAD diagrams, which the customer already has. And once you have this, we have an AWS SDK, which sits on your terminal, and that is when you start building the models based on mathematics, physics, and first principles. And once when you do this, you can connect this with the AWS cloud ecosystem. That is where the Bosch software would get installed in the customer's tenancy, and then you have the insights coming out. It could be the bearing issues, seal health monitoring, cavitation, mechanical issues, and so on. But the most important thing here, which you're seeing here, is the MCSA, the motor current signature analysis. Anybody in the world can do magic the moment you have sensors. But have you thought, if you're in a position where you can't put sensors, you can't take the data out, how will you manage such a machine? This is where Bosch, AWS, and our partners work together to bring an innovative solution to the market where you can assess and monitor the asset which is down below, which is invisible to you. So how did we do this? When I talk of MCSA, let me explain that to you in a very generical term. MCSA is like ears. Yeah? We build the ears for the pump, and when you have ears, you can listen. But if I may give a common correlation, what exactly MCSA does, there is a very common correlation which you can easily associate, right? Look at this. What every kid does, if the kid needs, it could be a kid of 5 years, 10 years, or it could be whatever it is, even a person with 40 years. One person with whom the kid typically talks is the parents and typically the mother. And what happens here is the mother always listens to the child to understand what is the problem the child is facing, right? And if I convert that into a data format, this is how it looks like. Very complex information she is speaking, but her mother is understanding only the key trends which she is trying to speak of, and then she makes an analysis of how a mother can help a child. And this is exactly what we are doing with motor current signature analysis of the pump. So if I now convert this technically into a motor current signature analysis, this is what you look like. You have the pump, you have got the power plant. What we do is, we access the motor control center or the drive control center which drives the pump, and inside the panel, we extract the information by connecting this terminal to the CT or the current transformer, and this is how this sensor would be positioned. And the best part here is, this sensor can write the data directly onto the AWS IoT core, which makes it very simple. And for live data streaming, when we have a kinesis environment, even the representation of data with the timestamps is very, very easy. And then we have the Bosch solution getting installed there, and this is the outcome that you get. It is like a stethoscope when you want to measure the heartbeat. It is like an ultrasound when you want to monitor how the development of a child is going on in a mother's womb. In the same way, this system tells you what is happening inside the pump, which is 700 meters to 1 kilometer down under earth. But how did we do this? It's good, but how did we make it work? How did we make this real? Again, basic science. We combined physics with AI. The old school physics with the new school AI was being combined, and the outcome was fantastic, where they were able to convert the insights into outcome. So again, going back to this, we needed physics to understand what's happening, and we needed AI to understand how the pump should actually behave. In the sense, what the pump should be doing and what exactly it is doing. This comparison by applying physics and AI. And we provided the data models, we provided the physics-based models, combining with high-fidelity simulations, and we created the hybrid models, which became the brain for this pump, and the MCSA was the ear for this. And once when you had this, all the deterministic models like fluid dynamics, thermodynamics, rotor dynamics, and electromechanics. Fluid dynamics tells you how the brine is being taken out from the Earth's lower part. Thermodynamics tells how the heat exchange is happening. Rotor dynamics tells the movement of the shaft of the pump, which creates a vibration. And finally, electromechanics, which tells you how the motor is behaving electrically. When you have these deterministic models, this is when you get this level of sophisticated insights. And these insights look sophisticated, but it's very simple. It is not telling you what you should do, but it's telling you what you should not do. So with this, things like wear out, gas leak, and imminent failure patterns, all these complex phenomena which you cannot sense, which you cannot measure, will be made available to you on a dashboard like this. These things are very difficult to measure, difficult to predict, but with this hybrid modeling, we can efficiently get this data out. But how did this happen? It's not that, we built a model, it worked. No, there was a backbone for this, which facilitated. And this backbone was lying on AWS ecosystem. That is where we harvested the computing, networking, and most important of all, the storage facility which was available on the AWS environment. Here you see the pump is being connected to the MCSA, and then the IT/OT integration happens. So the IoT core of AWS is so sophisticated, it can take data up to 12 kilohertz. At the same time, you can easily integrate the IT/OT data. Then following this, the time streaming, the live time streaming of the high frequency data can also be done using the Kinesis environment. And the best part was using the AWS environment, the Lambda functions, very specifically, and the ECS functions to run the physics-based models and the simulations, which is very difficult to run. And at the same time, the SageMaker that we have, there we ran the machine learning and AI models, and we were able to fuse it together and then create an insight which the customer had initially thought they were not able to gain those kind of insights. And then come the driving business outcome. All these things are technically fine. It's fantastic. It's happy engineering. But what matters at the end of the day is what business outcome that you are delivered, and were you able to measure what matters? Were you able to monitor, diagnose, and learn? This is where things get interesting, fellas. We have AWS Box environment where the business outcome acceleration is being done. And with this platform, we were able to network with multiple partners. We partnered with AWS, we partnered with Pepperl and Fuchs, and this platform gave us an opportunity to build solutions, not from scratch, without reinventing the wheel, but build the connected consumer and cognition layer with partnership. And with this partnership, ladies and gentlemen, I'm very happy and proud to say, today our solution is working on the largest German geothermal circuit. This is called as Project String of Pearls in the area of Munich, together with Stadtwerke München, and making sure that in the winter season, the people or the citizens who are there are not having tough time. And this is the largest network in Germany where digital twin that we have built together with AWS and Pepperl and Fuchs is being used to monitor those critical pumps which you cannot see. And if these pumps are not there, you can easily understand and assess what and how things can go wrong. Now, what was the business outcome actually? Exactly. One, everybody says, I have a sensor, I have a recommendation. I can tell you when the machine fails. But with this solution, we spoke about the functionality loss. It's like heart. When somebody says they measure, do an electrocardiogram, say the heart is going to give up. But here, using this system, we are going to tell the functionality loss of the pump so that you don't have to wait until the failure happens. So this is based on symptoms. It's not based on the actual measurement. Then, when we are doing this, maintenance, we call as predictive maintenance, but with AWS and Pepperl Fuchs, we are able to convert this predictive maintenance into surgical procedure. That is, you are interfering only when the intervention was sought, because you had all these degradation graphs or curves which you are able to see a week in advance so that you can actually plan this. The third one is improvement in the uptime, which you all know, everybody talks of OEE, but this system is telling you how to keep your OEE up, not tell you how to run and how to have an OEE to the greater value, but what methodologies. But the final or the resultant I can say is the system was able to prevent risk from evolving into a big problem. Nobody likes problem, right? And then how to prevent this event and avoiding that to become into a bad consequence. And finally, reducing the effect of the event. And these three sentences are very powerful because the people who are working on the ground, handling such a very complex asset where you can't reach, you can't see it, but you can only feel it, this brings happiness on the smiles of those people who are maintaining this kind of very complex assets. And the best part is when the customer uses such a solution and gives a testimonial like this, the Bosch Digital Twin IAPM is our decision-making partner. Three simple words: decision-making partner. This is what the value we have delivered. Other solutions typically are built to create impact. But here, Together with AWS and Pepperl and Fuchs, harvesting the AWS box environment, we built the impact. And it was a participative solution. It's not that only Bosch delivered it. The customer was a part of the solution building activity. Therefore, we help the customer to grow AI organically. And when people start adopting AI, physics, hybrid modeling, compute, network storage, all these things, then scaling is concomitant. You don't have to plan for scaling. You don't have to plan for an industrial data strategy. It becomes a concomitant factor. And that's what we have delivered to the customer. And we will work on this in the area of sustainability, energy, to ensure any companies in the world who are working towards energy resilience, Bosch, AWS, and Pepperl and Fuchs would join hands with them and provide this kind of sophisticated yet simple environment to keep their plants running in optimal cost mode and optimal efficiency mode to address the challenges of changing times. Thank you.